Hello and welcome back to the development of the Feersum scheme compiler. So in today's episode we're going to hopefully wrap up the work that we've been doing on supporting importing of Lisp or scheme libraries from .NET assemblies. Let's start off by going over what we did in the last episode. So in the last episode we did some work in the built-ins module so that we load some of the we load some more of our imported code using Mono's assembly definitions for reflection rather than what we previously used to do, which is using actual loaded .NET assemblies and .NET like style reflection. And what I'd like to do in this stream is to go over some of the remaining places where we use .NET reflection and convert those over to using Mono style loading of assembly references and walking through the metadata in that way. Ideally, the code that we emit and the references that we make into libraries should be dependent on whatever we're targeting rather than what's happening at the moment, which is depending on where the compiler is running, depending on what the runtime is, we will emit different references. So at the moment, the compiler runs on .NET 5. So when we emit a reference to the constructor for system.func, for example, we'll emit it based on what we find in our currently running process. So whatever reference assembly we've got, whereas ideally what we should be doing is loading in the .NET assemblies from an SDK and referencing those. We're not going to do all of that today, but I would like to do some preparatory refactoring by going over import load core types, which at the moment is using the actual .NET assembly. I'll have a look at all the different places we actually use. So one of the good ways to find out places where this could be an issue is where we're using type of. So we're using type of here to load in the actual assembly. So we're just doing like type of, and then we're looking at our copy of the Serifa assembly, which is our core assembly where we define things like cons pair. And we're just getting the assembly out of that rather than loading something from a path on disk. We've also got all of these attribute usage. So each one of these attributes will be making a reference it because we'll be doing main module import reference for some type or some constructor, which will be importing a reference based on whatever it is that we've got loaded at the moment. So we need to go through and change each one of these. So like the debuggable attribute, runtime compiler generated. So each one of these, we should hopefully move into core types. So instead of doing type of here, we do like add simple atter and then core dot compiler generated or something. We actually do that in some places already. So for example, for the undefined instance, which is when we load an instance of, we have a specific class that represents undefined values in scheme. So when we emit a call to load that, we do that out of core types. And we reference the things like cons creator and identifier creator and stuff like that from there. So we just need to go through and make sure that load core uses an assembly definition from Mono instead. What I think I might do to help here is just change this to be Sharifa assembly location instead, and then anywhere where we are referencing the path, we can load it like that, and now we can pass in mono, which we should now be able to rename to now. Load core types is not happy because it's expecting an assembly, but we need to use an assembly definition. And I think we should, I'll just fix this up. This is one place where we were properly using the location of the assembly and loading it in mono style stuff. These red squigglies now should represent the places where we initially want to fix things up. So these are those types that I just showed being used in the compile when we're referencing like the undefined or identifier constructor. It's these bits of code. So we'll need to do yeah, so I think what we'll need to do is make these get type calls. We need to do something different here. So let's just try it. Let extern cons tie, not cons. And then we're gonna do extern types. We need to do main module type. Do you want to go type system or exported types? What's in type system? So this is all like built-in thing. What's core library? So that's just where the, like whether we're using MS Core lib or system runtime or something like that. So I think this type system is just the built-in things. And get type is getting the type, the runtime type of the type system, not what we want. So I think we want exported types. And this is going to be a collection of exported type. So if we pipe that to seek.find, And we'll pick it where name. Well, we know the full name is, and then this. And then we can hopefully replace that with that. And no overloads. So do I just want to do types? I don't know. Yeah, looks like it. And then if I do import reference there, I'm going to get a type reference. Why do I need to call resolve? There's no. I don't think that's going to do. Unless that's forcing the master data to get loaded or something. I don't know. Leave it in there. So instead of doing extend cons tie, I guess we'll call this get type. And we'll call it the same way it used to be. Then each one of these just needs to be get type. And then from then on, we're actually already into the land of mono reflection, because the rest of them are just walking over the constructors and stuff like that from this metadata that's returned from resolve. I'm not sure if I've made a mistake or if syntax highlighting is just not caught up. There's a lot more green here than I was expecting. Green means functions, so. Has that worked? I don't know. Looks like it. Let's run the tests. That solves that. Where else are we using assembly then in here? But make it the whole word. So we're using it there to work out the location, and in a comment. What about our other types? So we could kind of do with knowing where these end up getting resolved to. So you've got the debugger, non-user code, step through. Because if these are all in the core lib, we can probably, it'll probably be pretty simple. Let's try first here to get this from core. So first thing we want to do is go and add a type definition into the core types. It's going to be a method reference. And then when we create this, we are going to need to set it. So that's going to be what we'll do is func_tie let func_tie. I'm going to try and rewrite this code to match the style of what's going on. So that we can hopefully abstract some core. Because there's several things here where we're creating a constructor. It'd be nice to have a helper method for finding a constructor, I think. Import reference, get type. And that's going to be, well, what is the type here? System.func. But the question is it this? That's going to be Lisp assembly main module. So that should still do the same kind of thing. It's just we'll see what we end up with when we call get type. I suspect that this is going to throw. So let's go get a debugger attached. And we'll just ask it to compile some nominal thing. This is going to throw before we actually get round to it doing any compilation. Get some. Let's clear out all of the old debug symbols. So breakpoints, and add that new one in. An index satisfying the predicate was not found. What a surprise. That's because I put that in the wrong place. But We've got the external assembly here, so we can look at some things. So if we get the main module, we were going to try and pick we've got exported types. Oh, there's nothing in there. We've got the type definitions, which I think must be in the more section. Yeah. But we got the core library as well. That's our types again. We don't have. I don't think we have a copy of the loaded version of that library. We've just got metadata about the assembly reference. Unless this is any different. I suspect these are just the same property. So where we call load core types, we probably want to pass in a sequence of assemblies. Maybe. Then instead of doing this, we'd need to do seek dot seek.concat well, we do extern assemblies seek.select well, really we just want to do a try find, don't we? So if we do try pick, I'm just gonna pick is gonna do assemblies types. Try pick. Or we can do try fine. And then the same predicate function that we use down here. Why do I need to annotate that as an assembly definition? I don't know. Assembly definition, because I need to do main module types. Then that should annotate it. Oh well. We can do a this will throw if it can't find any of them. Oh, I know I've messed up on the type annotation there. Which leaves this one last thing. So can I just open Mono.Cecil in here? Because that'll be useful. Fair enough. Oh, but I don't even need it. I've already got it open somewhere. Assembly definition. Expecting a string. Hi, I'm on Fedora 34 at the moment. Cosmos Dreams is. What distro do you use? Yeah. I used to use Manjaro, but I switched. It's a little bit more stable, and it's quite nice to use as a dev operating system. Don't need to do any hacks to get .NET installed as well, which is a positive. Are you sure that you're not happy with that? Maybe if we just do this. Now, it really doesn't seem to think. Because it says, I prefer Debian on desktop, but it does have outdated software. I used Debian, but never for that long. Yeah. It's stable, and I guess it's a good operating system choice for server stuff, but saying that, we tend to run a lot of stuff on Ubuntu just because it seems to have become a standard. Either that or Core OS in containers. People like Ubuntu because you can apt-get install, and that's what they recognize. Let's try and put this next to this and see. There must be something. There is. It's not called object. Let's run the debugger and see. Fingers crossed we're able to load that. This system.func type now. The thing I'm not fully sure of here is exactly what the full name is going to be and whether or not we're going to need to do anything special to make sure that, because there's multiple different system.funcs which are all different types with the different arities of functions. So we'll need to make sure we get the right type, which we're doing here by just doing type of that. But obviously this is getting the type from our current run. Debugger's not happy. I think it's because I accidentally typed into its console. Let it create a brand new console and hope for the best. So let's step into get type. So this is ours, which is not going to have it. Now we find out. Please enumerate. Signature, module handle. All these interesting. Yeah, look. So action is generic in the same way and has its arity packed on the end. So I think we should be good. I think this might actually return something. And then Can I get the constructors just directly off it? We've got is generic instance false? Has generic parameters true? And we got T and T results. I don't know whether or not we need to like resolve those generic parameters before we can get the constructor off it. We'll just give it a go getting the constructor off it directly. So let's func obj ctor equals, and then we do func tie dot get cons. So what's now we need to do dot resolve. Get constructors. And I think there's probably again just going to be one of them. So let's see what that ends up being. Because it could be that that constructor is that there's more than one or something. In fact, we could easily check by reading the docs, but we don't need a breakpoint there anymore. So we got methods. Is it going to be in? Yeah, there is only one constructor. So we're probably going to be all right. Because you've got the invoke, begin invoke, end invoke. So carry on. That looks like it works. Semi asks, what is your favorite programming language? I don't know. It's a difficult question. I'm writing F# at the moment. I like F#, but it's got its downsides. Quite like Rust. I think there's things like Python and Ruby that are quite nice because they're pretty simple, but kind of like type systems. So it compiles fine. But fails at runtime. Pretty much all the ones that actually expect to run are failing. So let's find something that's... Let's do something that's super simple so that we know when it... We can compare the IL from before and after, and then we can maybe work out what we're doing different. So we're literally just going to do display. So hopefully that should have generated as a hello.dll. We have. So let's IL spy. Here it says minus C++. I hate Python because you have to set the tabs right. That is, yeah. White space sensitive languages can be really annoying. One that's always gets me is YAML. It's not the world's greatest fan of white space. Show IL spec bin. No. Bin hello DL. Image is too small. That's not great. So it's not been written properly. Let's just try compiling it ourselves from the command line. Donut run project Feersum spec hello output to spec bin. Fair enough. It's not compiling. We need to do import scheme base. That was probably an error before. We just didn't see it in the avalanche of other errors. Still reference to undefined. Is this? Ah, because it's scheme right. It's not that library. Right, so we now have, hopefully, a compiled library. And I can do that IL-spy command again. Nope. Image is too small. But it produced an exe because I didn't tell it not to. Right, finally some IL. Is this what we want though? So that's saying system private core lib system.func tick2.ctor object native int. I mean, that it's this bit, isn't it? We need to add those generic parameters in because there's no actual type func tick2. This is a pain. I suppose the advantage here is that if we can do this with generic types, we can do it with non-generic ones easier, more easily. So func2, we're going to need to do something. So do we need to do it before or after we resolve it? Is generic instance, blah, 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 blah. There's usually like a make. So we've got make array, make pinned. Make generic instance type, maybe? Okay. Type references. This is what we want. And then we could do main module type system. So we want this to be a function that takes an object array. Make array type. And it takes an array and returns an object. So we can just use the same thing. So I'll rebind that. And then we can call .resolve on it. Then we call get constructors and go from there. I'm optimistically running the tests. They won't have got worse, right? well, they don't necessarily appear to have got better. Could not load type. Let's do that compilation again. Oh, this is the debugger's command prompt. So the bits we think are right is this bit. So that's got those types on it. But why is that not got the types on it? We'll just have to have a look here. Spec. Unless we need to call .resolve. Well, we'll see. We don't need to waste any time parsing more characters. Let's use our tiny example. So what is functi now? Generic parameters. Still t in result. Would there like be as generic parameters? Contains generic parameters is false. I wonder if we need to call .resolve first. And then add the generic parameters to it. Does that even work? Do we need to call .resolve twice? Don't know. It seems like maybe we might need to call make host instance generic. Maybe. Maybe we just need to call import. No, because we can only call import reference. So let's have a look what Stack Overflow has to say on this. So the example here is that they're trying to call lazy t and func t, which is good because that's what we're after as well. Hey C Films, I'm good. We're just struggling with Mono trying to import a reference to a generic type. It's not emitting the right IL, which I'm pretty confident is because I'm not importing the type properly. So our assembly isn't referencing it correctly. So it's calling import reference, make generic instance. It's calling module definition. So it's getting the func type, and then it's import referencing the function, and then calling make host instance generic with the same thing. So we import. Okay, so it's import referencing the type. Which I think is what we're doing here. To import reference func t. And then to get the constructor, calling import reference on the constructor, and then calling So it's in. I think we're matching up until there because we're called that says generic instance type before it calls resolve. Yeah. Oh. So we've got, I think we're the same up until then. Then they're calling import reference on the module for the constructor. So we're getting the constructor calling import reference on the module. And then with the result of that, they're calling make host instance generic. Now it'd be passing in the same types. Make host instance generic is an extension method which does some stuff. Take some type reference arguments. So this is what we're going to actually have to do. So it takes the name, return type, declaring type, makes an instance. Is something like this in Mono.Cecil. Films asks, how's the compiler coming? Good, I think. With I was hoping that this would be a simple stream to finish off the move away from using .NET Reflection so that we could use Mono's Reflection, and then at some point in the future we'll be able to support compiling for like cross-compiling, where we run the compiler in .NET 5 and we can target .NET Framework. But Mono.Cecil's Reflection is proving to be awkward. I probably shouldn't have dived straight in with this func object constructor stuff. So what does it actually do? Where does it use those arguments? So it's just making a copy of the method reference. But for the declaring type, So it's doing. I mean, can I do func object Ctor with? No, because it's not a record. Is it? It thinks I want to copy it now. So new method reference, which is going to take a name, which is name. And then func tie. We need to add. So we'll do generic Ctor parameters list.seek.iter. So add those. And then it also said the generic parameters need to be added. Which we need to pass in a reference. So we're going to have to do generic parameters map. What's reference? This method, so generic Ctor. Oh yes, because we're attaching them to that. Then we add them on that. And that's starting to look like it's a long enough pipeline that we want to wrap it. Then that might work. I was also optimistically hoping that we could share some code from this code that's getting constructors with this. And that's also not worked. System void system func is declared in another module and needs to be imported. as this, explicit this, and calling convention all need to be copied over as well. But don't think this is going to be the problem. Try it just in case. So something's not right. We're copying over generic parameters. Make host instance generic is taking a method reference. Let's have a look back at the IL, see what we're ending up with. Oh no, wait a second, we're not ending up with IL because it's refusing to emit it. Back to the debugger then, I guess. So does this have generic arguments now? We were attaching it to the wrong type by the looks of things. Why? It's not because of the resolve call, is it? Not 100% sure yet what resolve does. I think it turns like a reference into the underlying thing. So in that case, it's turning a type reference into a type definition. Turn a method reference into a method definition by actually loading it out of whatever assembly. Let's give it another go. Generic parameters, still empty. Not sure if that's even a bad sign or not. I mean, like, we did try and add them here. Oh no, wait a second. The generic constructor has no generic. Maybe this is right. Maybe. Yes. Look, it's system func tick2 system object array system object. So that bit's working. And it might have just worked. Let's try running the compiler and see whether or not our IL ends up with the right stuff in it. If so, we're gonna not touch that code. One last test. Does it run? No. It doesn't run. The func tie was right, though. Let's just trash the binaries directory. Then we can rerun the compiler and just be 98% sure that what we are trying to run is the same as what we've just produced with the compiler. It's in script body. Calling script body. Well, that's unfortunate. Right, what I'm tempted to do here is to go have a look at what we've changed. Stage what we can. And give up on the generic type stuff for the time being. So all of this stuff was good. So loading core types out of assembly definitions. And then what we'll try and do is just smash in this change. So this bit of reflection will still work, even though it's not doing it properly. So we can actually put like a fix me. No, I've not copied it. Or is this a bug in code because you can't copy deleted stuff? No, you can copy deleted stuff. Yeah, so just put that like that and then do end. And then hopefully that will compile. Oh no, it won't, because that needs to be Lisp assembly. That should compile. Looking at, I was going to say a lot better. Fingers crossed we end up with 2 failures just because there's no snapshot for hello. And we can generate those now. So then changing compiler to use funcobject-ctor. And built-ins, we want to change, probably just change built-ins to have funcobj invoke. And we can do let func. Let's go find out what the compiler currently does. Func_invoke is this bit. Do the same hack. And then down here. And up here, we need to add in func_invoke. So where else are we using type of? I was already searching for it. So we're using it more in built-ins now, but let's just not look at that for a while. IR helpers, type of exception. So we're only using assembly here for the constructor reference. So we might be able to get away with that. And add that to the core types. Exception CTOR. Is that even how you spell exception? It's apparently how I spell exception. And then I can do this and change this to be let ex tie equals main module import reference get type for sys, then excetor is going to have to be did I call it that? Do you even need to learn how to spell exception? Is going to be exception type get constructors seek dot find parameters count is 1. The first parameter, is that going to allow me to do that? Dot type I'm going to want core types in here somewhere or other. Main module. I don't know if it's going to end up being the same type. If we get it from our imported reference compared to the type from the core libassembly. Dot name string, I guess. Something like that. Yep, because that needs to be core dot exception. Is that really the only place we emitted a throw? Or is it like a helper method? No, yeah, it is a helper method for. It's the only place where we're emitting an actual throw is when we're. Okay. When we've done argument count checking and it doesn't match. Object constructor. We've got the assembly here. We can just do assembly type main module type system object. What's gone wrong here? Oh, because that's get constructor. Whereas you need to do get type system. Main module object get resolve get what? Type definition. What are we doing over here in built-ins? That's a type definition, and you can do get constructors. Ah, it's from rocks. Well, we should get Cecil rocks in here as well. So we need to do like resolve dot get constructor get constructors Then we'll do seek dot find one where it's got no parameters, and then we'll do import reference. So that's hopefully got rid of any type badness from IL helpers. Nope, it's not going well. We're not importing exception. Yeah, we're not importing. It's looking good. Remove .NET reflection from L. Then that leaves us only with, we're ignoring the built-in stuff at the moment because that's hacks. Add simple attribute. Well, I guess add simple. It's taking a type. Really, what it wants is the method reference. So we can go through and move all of those three into built-ins. Not do it there for the exception because we want these are actually all this constructor here and this constructor are just parameterless things. So we can actually refactor this out into let get single CTOR is going to take a type name, and then it's going to do that. And then it's going to do get constructors import reference. So with get single CTOR, we can do the same thing for the ident. And let compgen CTOR equals get single CTOR. And this is where we find out whether or not we actually have that. We need to do get type for cons pair as well. Compgen. Then if we make this take core.comp core types is not defined. And then this takes a method reference. And does attribute constructor. So is that going to work? Because the risk we run here is that those attributes aren't actually part of calllib. That needs compile. CTX is not defined. Wow, we just actually can just pass in core types because we only just made it. And that's going to be context core. Run the tests. Well, that went well. Index satisfied the predicate was not found. Yeah, so... MS Core Lib. Hello? No. It might not actually matter that I've typed in a bad name. No, it does. I didn't know whether or not we got that far in the compilation. Spec. Hello. So, according to the documentation, you should have a constructor. So, can we get your type? No. I wonder about we got that type system core library thing. Can we but core library is MS. It is this system private core lib. Right, we got the nullability attributes in there. I mean, there's thousands of types in here. Ah, system.runtime. Naming things. So let's try doing the same thing. test task, please. So non-user code and step. Non-user code. Non-user code and step through. Then back in the compiler, we can diagnostics debugger mark as, there we go, non-user code step through. Making some progress, hopefully. Lisp library. So we've got Lisp exported type, Lisp library. And so it's just Lisp export and Lisp library. So let's go and get those. Well, actually, we can hopefully do get single seater here. For both. This one wants to be that, because both of them, although, because get single seater is just taking the first one, it's not actually caring about what the arity is on the constructor. And do we have a refactoring for inlining these? Well, I'll leave that. And down here, instead, we can do can we? Or we can maybe just do core instead of context. We want this library. Yeah, that needs some type annotation. And that needs to be built-ins. Same thing here. This can be core.list. Lisp export. Both those can be a little bit shorter now. I think we need to mark with this needs to take context core and pass that in. Assembly configuration attribute. Again, we only have a single one. So we can do system.reflection.assembly configuration. Built-ins. So we'll add it up here first. It's a method reference. And that wants to be system.reflection. Over in here we can do do we have the, we don't. Core.asm. Mark as debuggable. going to need to pass in core. Ooh, interesting. Don't actually have access to the core types yet, do we? Well, we can move that down. There's no reason that's being done at that particular time. Runtime helpers, initialize array, value type. Debuggable attribute. Debuggable has more than one constructor, and that's going to be more awkward. Do we not have main module? Is that not the value type? Nope. Apparently you do need to do it that way if we want to make a struct. That's really awkward. What I think I'm going to do is commit what I've got and then just go through and clean up the remainder of those between streams and see if I can work out how to actually sort out that constructor. For system func. Right. Thanks for watching, and I will see you next time.